Hey there, Foundations. We're going to continue in Unit 4 today with 4.6 on point slope form. The objective of this lesson is to be able to use the point slope form of a linear function to be able to graph the function and model real world relationships. There's a pair of standards that go with this, FIF4 and FIF8, dealing with the key features of functions and being able to translate between different forms. We're not going to do too much of the translating between different forms today. We'll do a little bit here with this first example, but we'll hit more of that as we get to sections 7, 8, and 9. All right, so let's start off with talking about what is point slope form. And I want us to think about first the slope formula. And so remember when we talk about the slope formula, right? That's the one that says m equals, and y'all should know this one by now, right? M is equal to what? Y2 minus y1 over x2 minus x1. Remember, it's the change in y, that little delta symbol meaning change of, right, over the change in x. And so we're able to manipulate this formula into a new form. And so what we're going to do is I'm going to relabel a couple things. I'm going to keep the mm. I'm going to change my y2 and my x2 just to a generic y and a generic x. But I'm going to leave my y1 and my x1 still with the ones behind it. Okay. Now, I'm going to do another step here, and it's to get rid of this denominator. Well, remember, the denominators are division, so to undo division, we have to do what operation? Multiplication. So I'm going to multiply both sides by this denominator. And so this part cancels this part. And so I'm going to rewrite this next line. I'm going to put the m in front. So m times x minus x sub 1 is equal to y minus y sub 1. Now we're used to seeing the y's on the left side and the x's on the right when we solve these out. And so I'm going to just flip that around using the symmetric property. And I'm going to get y. Let's get rid of that little dot right there and there. Y minus y sub 1 is equal to m times x minus x sub 1. This is the point slope form of a line. Now, let's talk about a couple things that are in this. And so the x1 and the y1 become any ordered pair on this graph. And again, it could be anywhere on the graph, x1, y1. So it could be the order pair 2, 7. It could be the order pair negative 1/2 and positive 3/5. It could be any ordered pair on the graph. And remember that the m stands for what? Well, it's the same m from here, so m is still the what? Slope. And so when we look at point slope form, it's a really nice form for graphing from. And it's also a really nice form for where we have certain given information, we can write the equation very quickly. And we're going to see that with the examples that we do today. And so first example we're going to do is to write the equation in point slope form of a line that passes through the point 4, negative 3 and has a slope of 2. And so remember that point slope form, y minus y sub 1 equals m times x minus x sub 1. And I'm going to label my points here. This is my x sub 1, this is my y sub 1, and of course my slope is the m. And so I just plug everything in. So y minus the negative 3 is equal to 2 times x minus 4. Now this double negative will simplify, and so we're going to get y plus 3 is equal to 2 times x minus 4. Now I know what some of you are thinking. You're like, so my next step is to multiply this 2 in. No, don't do that. Because point slope form, if we go back up here, look what it has. It still has the parentheses, right? So we're going to stop right here when we're asked for point slope form. Don't get in that little habit of wanting to multiply in to distribute the number that's out in front of that parenthesis. Don't do it. That's it. I don't know why people try to make point slope form harder than they make it, but it's really an easy form to use. And it's, I almost want to say as easy as slope-intercept form. I wouldn't say it's easier than slope-intercept form, but it is more useful because you can use any point and not just the y-intercept that you have to use on the slope-intercept form. All right, so let's look at example 2. Same as example 1, right? So let me have you pause the video here, try this problem, and then let's see if you get it right. So pause the video for a second. All right, I hope you paused it. So let's look at this problem. So this is our x sub 1, this is our y sub 1, and this is our m, because we're plugging into what form? Point slope. And so y minus y sub 1 is equal to m times x minus x sub 1. And so I'm going to plug in everything that I'm given. And so I've got y minus the y sub 1 is 4 is equal to the m, which is negative 2, times x minus negative 1. And especially when we're plugging in negatives, you always want to use parentheses. Here, it's not going to affect anything. In this 4 here, it's not going to be affected there. So simplifying the signs, y minus 4 is equal to negative 2 times x plus 1. This is my final answer in point slope form. Again, don't multiply out that 2 or the negative 2 in this case, right? Again, this is point slope form. Stop where we're at. So did you get that one right? I hope you did. Again, I hope you paused the video and actually tried it first. All right, so now let's talk the other direction here. Let's say I'm given the equation and I want to be able to graph this on the coordinate plane. We've got to be able to pull that information out and get it onto the coordinate plane. So we're asked to graph in example 3, y plus 2 is equal to 2/3 x, 2/3 x minus 3. And so remember that point slope form, y minus y sub 1 equals m times x minus x sub 1. So let's label out each individual piece. Now the slope's the easiest one, right? The m will be 2/3. But the question becomes the ordered pair. Here's the trick with the ordered pair. You see that in front of the x1 and the y1? What sign's in front? It's a minus sign, right? And so we've got to understand that when that minus sign's there, it's actually going to switch the sign that we see in front here for that y1 and x1 value. Think about what happened up here, right? When I plugged in the 4, what happened to the sign in front? It became y minus 4, right? And when I plugged in the negative 1, what happened to the sign here? It became a plus 1, right? And so those signs are going to lie to us in our heads because the formula has a minus sign in it, not a plus sign. And so when we write this ordered pair, we're going to take the opposite of what we see for the x and the y. And so this is going to be my y sub 1 here. This will be my x sub 1 here. So my y sub 1 using the opposite sign will be a negative 2. And my x sub 1, I see a minus 3 here, so it's going to be a positive 3. Now, so I've got my information. And remember, you only need a point and the slope to graph the line. And it does not have to be the y-intercept. And that's where a lot of students get confused that, you know, this is going to go on the y-axis. No, it's not going to go on the y-axis. And this is not the two intercepts. This is the point 3, negative 2. So I'm going to go to the point 3, negative 2 and put my point. My point is going to be right there. Now, the next thing I'm told is my slope is 2/3, which means my rise is 2. So I'm going to go up 2, and my run is 3. So I'm going to go right 3. So I end up here, right? So I went up 2 and right 3. And so my line connecting these points, if I go up 2, right 3 again, and I can also back it down in this direction, going down 2 and left 3 by inverting both signs. And so I'm going to get this line here. And so again, as you see, I'm drawing this line all the way across the coordinate plane. Don't just stop between these 2 points and be like, I'm done between these 2 points, because the line continues all the way through. Okay. And so again, when you're looking at these numbers here, right, make sure you're looking and taking the opposite of what you see for the x sub 1 and the y sub 1. So example 4 is going to be like example 3. I'd like you to pause the video for a second and look at this problem here. All right, so if you pause the video, let's see what you got. Now this one, there's a little bit of a trick to this one, because you got to think about what is the slope here, because y minus y sub 1 is equal to m times x minus x sub 1. And so the ordered pair is pretty straightforward, right? So I'm looking at my y sub 1 here. So my y sub 1 is going to be positive 1, and my x sub 1 is going to be positive 2. But what is the slope? I just have this negative sign sitting in front of here. Well, what number would go right here? Well, there's an imaginary 1 there, right? So my slope is equal to negative 1. And so where am I going to plot this point? Well, I'm going to go to the order pair 2, 1, which is right here. And my slope is 1, so remember I'm going to put that over 1 if it's not already a fraction. And so I'm going to go down 1, right 1. Again, the negative is only associated with the numerator, so my rise is negative, but my run is still positive here. And so I can go, again, down and right, and continue this line on down forever. And then I can reverse the direction and go up 1, left 1, because I can associate the negative with the denominator instead of the numerator. And continue this line up and left. And again, I don't have to put all these points, but it does help me keep this nice and straight as I draw this on the screen. And it might help you do the same as you're drawing this on your paper or drawing it on the screens when you're doing your work today. Okay, so again, it's not hard to get this information. It's just pulling the information out from the equation and being able to graph it on the line. So let's look at example 5. Now we're given a graph and we want to write the point slope form of the line shown. And so again, we're going to use point slope form. Y minus y sub 1 is equal to m times x minus x sub 1. And so I can use either ordered pair here that I'm given, or if I'm not given any ordered pairs, I can find just a point that's on the graph. I mean, we could talk about this point here at 2, 0, or this point here at 0, 2, right? Any of those points would work. And so let's talk about what we have. We need to first find the slope. So what is the slope of this line? Well, remember the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I can label these x sub 1, y sub 1, x sub 2, y sub 2, and then I will get 1 minus 3 over 1 minus negative 1, and so I get negative 2 over 2, and so that's negative 1. My slope is negative 1, and that makes sense because my line is sloping downward from left to right, and if I look, it's down 1, right 1 to get to my next box, and so that's where we're at there. Now, which order pair do I plug in here? Well, that's the thing, is remember that a line has a unique line, right? But point slope form is a little different in that I could plug in any point that's along that line and it still represents the same line. So I could write this as y minus, and we'll use the 3 since it's y sub 1, 3 equals our slope of negative 1 times x minus the negative 1, which is the x sub 1 here. And so y minus 3 is equal to negative 1, or just negative, times x plus 1. Now, this would be one answer. But I could also give the answer with the other order pair. And so I could say y minus the 1 is equal to the negative 1, x minus 1. And so simplifying this, y minus 1 is equal to the negative with x minus 1 in parentheses. And so again, this in the blue and this in the red are both answers to this problem because they both represent the same line. They just use two different points that are along that line to give the equation of it. All right, and so example 6, I'm going to ask you to do the same thing. Pause the video here. It's a little different, but again, I didn't give you the graph, but I did give you 2 points here. So again, pause the video and find the equation of this line in point slope form. Now, let's look at this problem. So I'm given 2 points, right? Well, that means I have to find the what first? I got to find the slope. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And if I label out my points, x sub 1, y sub 1, x sub 2, y sub 2, I'm going to get 4 minus 3 over 4 minus 2, and so that gives me 1/2. My slope is a half. Now, we go to the line. So y minus y sub 1 is equal to m times x minus x sub 1. And so y minus 3 is equal to 1/2 x minus 2. And so there's no simplification needed because there's no signs that are incorrect with double signs. Or, again, I could plug it into with the other order pair, y minus 4 is equal to 1/2 x minus 4. And so again, either one of these two are the correct answer. You don't have to give both. Typically with like standardized testing, they'll tell you to use a certain order pair, or they'll tell you to use the leftmost point given. And so let's look at the last example, just getting this into a word problem here. Your assignment's not going to have any word problems today, but I do want you to at least see one of these here, and we're going to talk more about the word problems in section 8 on Wednesday. Okay, so example 7, you're designing a sticker to advertise your band. The company charges $225 for the first 1,000 stickers and $80 for each additional 1,000. So it says write an equation that gives the total cost in dollars of the stickers as a function of the number in thousands of stickers ordered. And it says to find the cost of 900 stickers. Now, this becomes an order pair for us because let's back up a step because we really need to do something first. We need to ask ourselves, what is the independent variable and what's the dependent variable? Which one depends on the other? Does the number of stickers depend on the cost, or does the cost depend on the number of stickers we purchase? And so when we think about this, right, it's the number of stickers is the independent and the cost is the dependent, right? And so if I think about the order of this, x and y, I'm going to get the order pair 1,000, 225, right? But here's the trick on this one. It told us that the function is in thousands already. So I'm going to actually take these zeros out because this order pair is not going to be 1,000, 225. It's going to be 1, 225. Because again, our final function is already related to us in thousands. Now, the second piece of information, this line here, right here that I'm highlighting in green. This is the slope because they tell us for every 1,000 stickers that we purchase, it's going to cost us how much? 80. And so remember that slope, our slope is the change in y over the change in x, right? Or the change in our dependent divided by the change of the independent. And so remember that our dependent is the cost, and so it's going to be the $80 divided by the 1,000 stickers, right? But remember that our x is already in thousands, so I'm only dividing it by 1, not 1,000 here. And so my slope is just the $80, right? Because $80 divided by 1. And so now I'm able to plug this into point slope form. Y minus y sub 1 is equal to m times x minus x sub 1. So I'm going to get y minus the 225 is equal to our 80 times x minus 1. And so if I was just asking for the function, which it does here, it says write the function, right? Write the equation as a function of the number of tickets in thousands. So that's the first answer. That would be like part A. Part B, this says find it for the cost of 9,000 stickers. So remember that our number's already in thousands, so I'm not going to plug in 9,000. I'm just plugging in 9. And so I'm going to get y minus 225 is equal to 80 times 9 minus 1. So y minus 225 is equal to the 80 times 8. Y minus 225 is equal to 640. And adding the 225 to both sides, we get the y is equal to 865, meaning that the cost of 9,000 stickers, because again, we plugged in what number? 9, and we got out what is $865. And so again, not a complicated problem if you understand where everything comes from. And that's the struggle that we've been dealing with all semester, and those that I've had all year, that's a struggle we've been dealing with all year, is understanding what comes out where and where does it go into my problem? Where does it plug into my equation? So again, look at the pieces, read through the words. Don't just find numbers and pick them out and try and put them places. Actually read through the words and understand what they mean. Okay, we're going to talk more about this in section 8, like I said, on Wednesday. But for today, focus on examples 1 through 6, because that is what your assignment is going to hold for you. Again, don't forget about the Zoom chat from 11:30 to 12:30 if you need my help. And the word of the day is point slope form. That is 2 words, point slope with a hyphen in between, form. Point, slope, form. That's your word of the day, ladies and gentlemen. I hope y'all have a great day. Again, if you need me, email or catch me on Zoom. Y'all have a good one.